It must be a continuous variable and is naturally occurrence variable. For examples, the height, the weight, yeah? Okay, like for example, bags of sugar, 1 kg of sugar that filled by a machine. So it's naturally occurrence thing means it affected by many factors. Like for example, your weight. Depend on, can you tell me the factors? Why you all talk until so biology? I really don't understand. Okay, like for example, the weight of a person, okay, depend whether you are a person who is easily put on weight or whatsoever. First, genetical factor. Second, environment, the food that you take.
I couldn't find weight.
Okay, the food that you take, correct? And the things that you do every day, that will determine your weight. Am I right? Your metabolism rate. Yeah. The type of job you are in. Am I right? So all these factors. So when we talk about this, but naturally, everyone, okay, like at certain age, you definitely got certain weight. And as an adult, male and female will be different. So another factor that affect our weight is the sex, right? So all this. So we can, when we want to talk about certain things, we will say other variables are fixed. So all these natural occurrence things, all these are very fair. God is very fair to everyone. So that's why we will have the shape of the graph for this variable, continuous variable will be a bell shape. Yeah, so we call it normally distributed. Okay, normally distributed means it's symmetrical. So for a normal distribution, okay, statisticians have found out that the function, the probability density function. Okay, if you look at page 212, the probability 232, the probability density function for normal distribution will be fx equal to, okay, if you look at this function, 2, standard deviation, square root of 2 pi, then e to the power of negative half x minus mean over standard deviation squared. So the variable is x. Standard deviation and mean will be fixed. Are you clear? So if you plot this graph, for example, I say x is a normal distribution. The first number is the mean. So I say the mean is 5. Okay, and the standard deviation is 1, for example. So over here, we don't write standard deviation, we write variance. So that is how we denote a normal distribution. So now, if you sketch this graph, okay, you may want to try to key this into your graphic calculator. You may want to key in as y1 equal to 1 over the standard deviation is 1. So you put 1 square root of 2 pi e to the power of negative half x minus mean. The mean is 5 and the standard deviation is 1. So that means when you key in your calculator, you key in like that. Okay, the e here, instead of put half, what you can do is you can key in like that. Negative x minus 5 square over 2. Okay, you may want to try. Have you key in? Okay. Now, I would like you to, Dana, you key in the function area. So I would like you to find the probability that X is between 2 and 8. How you know it's 8? Okay, can you please find the probability of X between 2 and 8? Do you know how to get it? You go to your graphic calculator, you use FNINT, 2 to 8, your Y1 dx, correct? Because this is a probability density function. So you will get approximately equal to 1. Am I right? Am I right? So I just want to let you know that, for any normal distribution, can I move on to the next page? Yeah, for any normal distribution, if I put like that, my X between 2 and 8, do you know how I get the answer? So now I'm going to teach you how to get the graph without the graphic calculator. So the mean for this distribution is 5. So this means that I'm finding the probability that within 3 standard deviation away from the mean. Am I right? So if I say 3 standard deviation away from the mean, means, yeah, minus 3 times of the standard deviation, that is take away -3. So take away 3. So here is 2. Am I right? And here plus 3 standard deviation. I purposely write down 3 times 1 because my standard deviation is 1. So this is called 3 standard deviation. So 5 plus 3 is 8. So that means the chances of the variable X to be less than 2 almost negligible. Correct? And the chances of X more than 2 and more than 8 will be very, very unlikely. Agree or not? So that means the probability density function when X equal to 2 is almost touching the X-axis. Am I right? Hello? Agree with me? You look at your graph, you know, am I right? Because the probability for this one is almost 1, 0.999 something, am I right? Okay, so so for any normal distribution, it doesn't matter whatever the mean, whatever the standard deviation, I can make a conclusion of what? What conclusion can I make? All values of X are how many standard deviation away from the mean? So this is the first thing. Now, where is the inflection point? You look at your graph, there is an inflection point, correct? Okay. Where is the inflection point? There are two inflection points. One on the left of the symmetrical axis. The axis of symmetry is the mean, is also the mode, is also the median. Am I right? And the mode, that's why this point is the highest. Okay, where is the inflection point? You want to find it by yourself, or you want me to tell you straight away? For this case, if you want to know the inflection point, you have to plot the graph of y2, which is d over dx of y1. So I'm going to tell you straight away. Where is the inflection point? 1 standard deviation away from the mean. That is the point of inflection. That is where the point of inflection located. Yes? How do I know it's 1? If you don't believe me, you do y2, then you plot the graph of y2. Yeah, it's always 1 for normal distribution. 1 standard deviation away from the mean. Okay, so now I know where is it. So 1 standard deviation. So now this one I divide. So this is 1 standard deviation, 2 standard deviation, 3 standard deviation. So here is 4, here is 3, correct? Here is 6, here is 7. Am I right? Okay. Now, how far is it away from the highest point? So if this is the highest point, I will divide roughly into 3 equal parts. So here will be the inflection point. Okay, so that is the, every time when you want to sketch the probability density function graph for normal distribution, you have to remember 3 important points: the highest point, the inflection point, and the ending point. That's it. If not, you use your graphic calculator to help you. So the choice is yours. You try to get from your graphic calculator. Yeah, it's always around roughly. So we just sketch. Yeah, that is your f prime x graph, isn't it? The highest point, the turning point is 1, 4 and 5, 4 and 6. Yeah, I'm right. Okay, trust me. Okay, so the graph will go in this way. Okay, listen. This is concave up, then concave down, then after that concave up. So here we will put an arrow. Please don't make it touch the x-axis. So the area under this curve represents the probability. The area under this curve represents the probability. So which means that every normal distribution curve, regardless of their standard deviation and mean, the area bounded by this curve must be how many units? 1, because it represents probability. Are you okay? Got it? Now everyone know how to sketch even without the graphic calculator? The answer is a yes. Okay, so now if you now turn to page 234. If you turn to page 234, okay, do you need to memorize this? The answer is no. This is just give you a rough probability. If the value is 1 standard deviation away from the mean, the probability of it to happen will be 64.26%. Can you please go to page 234 of your textbook? Huh? No, you differentiate once can already. We are not going to do differentiation. You just need to go to your y2. You put d dx y1, x equal to x. So you sketch the graph, you find the turning point. That is go back to your calculus. Are you clear? So I'm not going to talk about calculus now. You just trust me. That is the way to do it for here. Are you clear? We have no time to go to the calculus. Okay, so for this case, so this is 0. This area is 0.6416. So in this case, since you got the formula in already, actually you can find this value by integrate from 4 to 6 your y1 dx. You see whether you get this number or not. Huh? 6816. Do you get that? You try and see, you will get that. 68. So this is more accurate in the sense. The one round off already. 6826, yes, should be correct. So for whatever normal distribution, whatever mean, whatever standard deviation is standardized already. Do you get me? So that is just a table for you to do as a guideline. Right? So do I need to memorize that? I don't have to. But for exercise 8C, yes, you are going to use all that to do. So in our actual situation, listen carefully, in our actual situation, we have a program for us to help us to calculate the probability. Okay, please. Now I'm going to teach you how to do it. Okay, using your GC. So remember exercise 8C, all the question you can use the graph on page 234 to guide you. If you don't want, also can. So I'm going to teach you how to use your GC. Okay, so my X just now is a normal distribution. The mean is equal to 5 and the standard deviation equal to 1. Right? Hello? Okay, so now if I want to find the probability of X less than 5, can you tell me what is the answer without GC? Less than 5. I can put equal, no equal, doesn't matter. What is the answer? If you cannot answer me, I think you don't understand the meaning of median. 50% because this is a symmetrical graph. The mean is also the median, also the mode. So what is this area? 0. You are toxic.
Recording in progress.
Because the mean is also the mode, is also the median. That is the meaning of symmetrical. So do I need to use calculator to calculate? No. Very sad. Okay, but now if I want the probability of X less than, for example, 3.5. Okay, in your high school, you have a table to help you, correct? And you have such thing as called standard score, am I right? For here, we no need. So please take out your graphic calculator. Go to distribution. Second, don't simply say first before I say. Second, var, go and select normal. I say don't simply say law. Normal CDF. There is no such thing as PDF, okay? Because the probability of particular variable, continuous variable to happen is almost equal to 0. So how can you use PDF? You must use cumulative. Okay, so now what do you have? Up, lower. In this case, 3.5, correct? Less, correct? There is no lower. So you always type in 10 negative 10 to the power 99. It doesn't matter whatever value. Always type in, if there is no lower boundary, always type in negative 10 to the power 99. Upper 3.5. There's no lower boundary. Mean 5. Standard deviation 1. Come out. 0.0668. Round up to 3 significant figure. Are you clear? Yes. Normal CDF means find the area bounded by this curve. There is no lower boundary for here. So you type in negative 10 to the power 99. Upper, you look long. You look at the equation, you tell me what is the upper. Here, look at the board, not look at the book. How can it be 5? I'm talking about this one, young man. You are always one step behind. Okay, got it? So that is how you use your normal CDF. So always use normal CDF. Clear? Hello? Okay. So now, if I ask you for probability of X greater than 3.5, do I need to use calculator? In this case, I don't have to because I have it in the first part. I can just take 1 minus 0.0668. Am I right? If you want to use a calculator, can or not? Can. Yeah, I waste time now, you know. So you also use normal CDF, and this case, 3.5 onward. So your lower bound will be 3.5, your upper will be 10 to the power of 99. Hello? Yeah, got it? So now you know how to use your normal CDF, very important. Okay? So now calculation of probability is extremely easy. Calculation of probability is extremely easy. Why? Because the calculator. Now, next.
In progress.
Okay, so remember, taller and thinner, shorter and fatter. Get the ratio of the standard deviation first, then get the ratio of the height. When you prepare the horizontal axis, prepare the one with the wider spread. So now, hello? So you know that the standard deviation of y is 0.25, right? Yeah. So 5 to 6 is 1 unit. So I divide into 4 equal parts. Roughly, okay, roughly. Roughly, 4 equal parts.
Must the boundaries always be b minus 3?
Yes, because that is your end point. Okay, so now I mark my horizontal, vertical axis. So I will plot the taller one first. So I will plot the blue one, the white. So highest point is here. If I say 3 standard deviation away means 5 minus 3 times 0.25. So what is the value? Calculator. Zero point 4.25, correct? 4.25. So 4.25 is here. Am I right? Okay. 5 plus 3 times 0.25. So it's 5.75 is here. Am I right? So highest point, ending point. So now inflection point here, somewhere around here. Yep. Am I right? Somewhere around here. 1 standard deviation away from the mean. Okay, get all these 3 points done. You sketch the graph. So this is your y. Can you? 1 standard deviation away. That is the inflection point. So memorize that. First, highest point, ending point, inflection point. Okay? So now I'm going to do for, can I move to X? Okay, X. So how high should the X be? This is the height of Y. So roughly here. Correct? The height of y I divide into 4 equal parts. X take 1 part. Agree? 1 part, 4 parts. Okay? So now, where is the ending point for X? Here. 3 standard deviation away. 5 plus 3 times 1. 5 minus 3 times 1. Where is the inflection point? Roughly here. Roughly here. 1 standard deviation away. Sketch the graph. If you don't want to do like that, okay, then you can use your graphic calculator, key in the 2 into y1 and y2, then you do a zoom fit. You put your x between 2 to 8. Are you clear? So the area bounded by the 2 curves is, okay, now, done? So this is a skill of sketching. Do you need to memorize all the steps? The answer is yes. Will I ask you in the exam? 100%. Okay, now. You get me? Which one you don't get me? Yes, why you use greater than?
The area under x less than 4 is greater than the area under y less than 4.
Yes. Do you get me? So the answer is greater than. Because x has a bigger spread. So the area bounded by the x curve that is shaded in black is bigger than those I shade in blue. 4 is here. You see the area is here only. The almost negligible, correct? Hello? Do you get me? Joshua? Are you okay? So we can ask you to sketch the 2 graphs. Then you are not supposed to do calculation. We can say based on the graph, decide which is bigger. Do you get me? But if I put another one, okay? If I give you another one, okay? Probability of x greater than 4.5 and probability of y greater than 4.5. So which one is bigger now? So you have to be very careful with the sign that I'm using. So which one? For the y is bigger, correct? So now the sign, I have to put it like that. Because the area to the curve of y to the right of 4.5 for y is bigger than the area of under the curve, bounded by the curve for x more to the right of 4.5. So greater, less than, it makes a vast difference. So all this you have to base on your visual and you decide. Always remember, area bounded under this, bounded by these curves represent probability. The total area is 1. So if smaller standard deviation must be thinner because the width is smaller. You get me? Good. Wonderful. Okay, now,
Recording in
if I
progress.
give you a variable x and I tell you it's normally distributed and I give you the mean is equal to 10 and the standard deviation equal to 2. Okay. And I say probability of x more than k is equal to 0.5. So k is equal to what is the value here? 10. Good. If I give you probability of x less than k is equal to 0.123. What is k? Okay, k is less than 10, correct. You straight away know k is less than 10. Agree. Perfect. So how to find k? K is 4. That is your wild guess. Correct? Okay, good. Now your graphic calculator can help you to do. Take out your graphic calculator. Tell me which one to use. Huh? Can use over? Can. Try not to use over. No, you still scroll down. You want to do the other way round? Yes, you have your inverse norm. You got your inverse norm? Below the CDF is the inverse norm. You have the inverse norm? Okay, so when you press inverse norm, what come out? Okay, area. So area means the probability, correct? Okay, probability. So the probability here is 0.123. Yeah, some more? The mean, 10. The standard deviation, 2. Some more? Tail. So now you have to decide, is it left? Is it center? Is it right? Now you know it's left. Why you say it's left? Because less than. So you choose left because it's less than. All right? So anyone without all these, just area, mean, and standard deviation, your graphic calculator, like mine? Hello? Yes, why are you playing with your handphone? Okay, so what do you get? So now if I give you the probability, do you know how to find the value? Can. So today we end the class.